Welcome to Solutions Studio. This is a free series on C programming language. If you like these videos, please subscribe to follow along with this series. Also, please like and leave a comment and share the video to help spread this series. Hello and welcome to this episode. And this episode we have an exercise for you. The name of the exercise is rounding numbers. An application of a function floor is rounding a value to the nearest integer. The statement that you can see in here rounds the variable x to the nearest integer and assigns the result to variable y. So we would like you to write a program that reads several numbers and rounds each of these numbers to the nearest integer. So go on and try to solve the problem and come back to this video for the solution. Hello and welcome back, and here we are to the solution of this exercise which we called random numbers. So I want to explain the solution a little bit for you. As you can see in here, we are going to use this variable to store the user's float number. Then we are going to prompt the user to enter a floating point number 0 to exit, and we are going to store that number in this variable. And then there is our while iteration loop, which checks if the user's float number is not equal to 0. If it's not equal to 0, then it will continue and it will create the rounded integer of the user's float number using the function floor. Then we are going to print the nearest integer for the user, and once again we would like to take the number from the user and check with this while condition if the number is not equal to 0. If it is equal to 0, then this while statement is going to be ignored and the program will return a 0 as the value of main, and the program execution will be completed. Also remember that we used this function floor, and this function is included in math.h header. Let's go and execute this program. Let's enter a floating point 9.76. As you can see, the nearest integer is 10. Let's try 23.3. The nearest integer is 23, and if I enter 0, the program is completed. Hello and welcome to this episode, and in this episode we have another exercise for you. This is also about rounding numbers. The function floor may be used to round a number to specific decimal place. The statement that you can see in here rounds x to the 10th position, the first position to the right of the decimal point. The statement, as you can see in here, rounds x to the 100th position. As you can see, we have used the quotient of 100, and also we have used the divisor of 100. We would like you to write a program that defines 4 functions to round a number x in various ways: round to integer, round to 10th, round to hundreds, and round to thousands. For each value the program inputs, display the original value, the number rounded to the nearest integer, the number rounded to the nearest 10th, the number rounded to the nearest 100, and the number rounded to the nearest 1000. Go on and try to solve this problem and come back to this video for the solution. Hello and welcome back, and as you can see here we have solved this rounding number exercise. Let me go through this solution for you and try to explain it a little bit for you. As you can see, we have our prototypes, all of the functions that we were supposed to declare. We have declared it here in the prototypes. The main function starts, we are getting the user's float number in here. Then using printf, we are prompting the user to enter the floating point number. Using scanf, we will store it in this variable, and the while loop will continuously run until the user enters 0. As you can see, we have got the number in here. We are going to print the original number, going to print the rounded to integer and use this function to print the value, and subsequently we'll print the rounded to tens and using this function to print a value, and going on we will do this like that, and the while loop will continue running until we see a 0 entered by the user. And as you can see in here, all of these functions are being defined and they are using exactly the same statement that was given to us in the question explanation. And that's how this program is going to run. Let's go and compile it and run it and see how it works. For example, I want to enter a number 45.7639. As you can see in here, the original number is 45.763901, because as we have said, the floating point numbers, they are always approximation. You can see the integer, you can see the tenth of this number, always approximation, as we have said before, the hundreds and the thousands. And that's it for this episode, everyone. I hope to see you in the coming episodes as well. Hello and welcome to this episode, and in this episode we have another exercise for you, that is the calculation of hypotenuse. So define a function called hypotenuse that calculates a right triangle's hypotenuse based on the values of the two other sides. The function should take two arguments and return the hypotenuse. Test your program with the side values specified in the following table. That is, one side of the triangle 3 and the other side 4, and as such the other values as well. So go and try to solve this problem and come back to this video for the solution. Welcome back, and here is the solution to the problem that we discussed previously. As you can see in here, we have defined the function which is called calculation of hypotenuse. It's taking two arguments, side 1 and side 2, and it's going to calculate the hypotenuse using this formula, which is square of side 1 and square of side 2, and then the square root of the addition of these two squares. As you can see, I have two variables which are called side 1 and side 2, and then I have stored the value that I got from the user in the side 1 and side 2 using scanf, and finally we have printed the hypotenuse using printf and calculated the hypotenuse using the function and provided these sides as arguments. Let's go and run this program and try these values. 3 and 4, that is 5. Let's try it once again. 8 and 15, that is 17. And as such, you can try with other values as well. Stay tuned for more episodes of C Programming Language. Hello and welcome to this episode. And this episode we have an exercise for you, that is finding the sides of a triangle. So we would like you to write a function that reads three non-zero double values as the sides of a triangle and calculates and returns the area of the triangle as a double variable. It should also check whether the numbers represent the sides of a triangle before calculating the area. Use this function in a program that inputs a series of sets of number and obviously print the area for that triangle. Go on and solve this problem on your own, and if you could not solve it, come back to this video for the solution. Hello and welcome back, and as you can see we have solved this problem. Let me explain this solution a little bit for you. In here I have defined and prototyped two functions. The first one is triangle is valid, which is going to check whether the sides of the triangle is valid or not. And secondly, the second function is going to calculate the area of the triangle. Then here in the main function, we will use printf to prompt the user to enter the sides of a triangle. We will use scanf to store those sides of triangle in these variables. And then finally, we check if triangle is valid. Then we are going to print the area of the triangle. And else, if the triangle was not valid, then we prompt the user that the triangle sides are not valid. Now here in the function triangle is valid, we have taken all of the sides of the triangle as an argument, and then we are going to use these inequalities. The rule of the side of the triangle says that the two sides of a triangle should always be bigger than the third side. So side 1 and side 2 should always be bigger than side 3. Side 1 and side 3 should always be bigger than side 2. And also side 2 and side 3 should always be bigger than side 1. And then if that is true, then we are going to return 0, which shows to this condition that triangle is valid. And if it's not, then we are going to return -1. And finally, we are going to use this function to calculate the area of triangle. First, we are going to calculate the semi-parameter. The semi-parameter is side 1 plus side 2 plus side 3 divided by 2. Then using this formula, which is the square root of semi-parameter times semi-parameter minus side 1 times semi-parameter minus side 2 times semi-parameter minus side 3. And I have found these formulas from the internet. If you want to know the explanation for these formulas, go and search on the internet and you will be able to find it also about this inequality about the sides of a triangle. So let's go and execute this program. Let's see, let's give it like 3, 4 and 5, the sides of a triangle. As you can see, the area of triangle is 6. Now let's go and put something invalid and see the reaction of the program. Let's say 45, 6 and 100. As you can see, the program is telling me that the triangle sides are not valid. Thank you for being with me in this episode, and I hope to see you in the coming episodes. Hello and welcome to this episode, and in this episode we have another exercise, which is the sides of a right triangle. So write a function that reads 3 non-zero integers and determines whether they are the sides of a right-angled triangle. The function should take 3 integer arguments and return 1, which means true, if the arguments comprise a right-angled triangle, and 0, which means false, otherwise. Use this function in a program that inputs a series of sets of integers. Now go and solve this exercise and come back to this video for the solution. Hello and welcome back, and this is the solution to the problem that we discussed about. First, in here I have the prototype of the function, which is going to find whether a triangle is right-angled or not. Here in the main function, we have prompted the user to enter the sides of a triangle. Then we are going to store those sides in these variables using scanf. Then we will check if triangle is right angle using this function. And if it was, which this value of 1 means true, which means that triangle is right angled, then we say that the triangle is right angled. And if it's not, we say that the triangle is not right angled. And how do we find if a triangle is right angled? We are going to take all of these 3 sides, and for a right angled triangle, the sum of the square of the 2 sides should be equal to the third side. So this is true for all right triangles. But since we don't know which side is which, then we have to check for all of the sides individually. That's why we have 3 conditions which we exchange the value of sides. And here we are checking for the side 3, which is going to be the hypotenuse in here we are checking for the side 2, which could be the hypotenuse, and in here we are checking for side 1, which could be the hypotenuse. Finally, we are going to return 1 if that is true, and we will return 0 if that is false. And we are using this value in here in the condition of the if conditional. Let's go and check the results of this program. For example, I will enter 5, 13, and 12. As you can see, the triangle is right angle. And if I put something else, for example 4, 6, 7, then you can see that the triangle is not right angles. Thank you for being with me in this episode, and I hope to see you in the coming episode. Hello and welcome to this episode, and in this episode we have another exercise which is called the rectangle of asterisks. So write a function that displays a solid rectangle of asterisks whose sides are specified in the integer parameters side 1 and side 2. For example, if the sides are 4 and 5, the function should display the following. So there is 4 asterisks in the height and there is 5 asterisks in the width, and this is how the function should work. So go on and solve this problem and come back to this video for the solution. Hello and welcome back, and as you can see we have solved the problem that we discussed about. Here we have used a function which is called rectangle of asterisks, and this function is going to be used to print the asterisks or the rectangle of asterisks. Now here in the main function we have used these two variables, side 1 and side 2. We are prompting the user and taking the values of side 1 and side 2 from the user. Then we are using the rectangle of asterisks function, and we provide it with side 1 and side 2 to print the asterisks. Here in the rectangle of asterisks function, we are using a for iteration, which the counter for the for iteration is line. We have named it line because the first for iteration is creating line. And how many lines it creates? It creates as many lines as side 1. And each time the iteration is completed, the line is added by 1. And as you can see, we can show you that this puts function is creating these new lines. But before each new line, we are printing asterisks. And for asterisks, we use the counter asterisk. It will start from 1, it will print as many asterisks as side 2, and each time an asterisk is printed, the counter is incremented by 1. And basically, as you can see in the second for iteration, we have used a printf of asterisks. And that's how our program works. Let's go and execute it. For example, we want to say the sides of a triangle is 10 and 12. And as you can see, we will have 10 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12 asterisks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And that's it for this episode. Stay tuned for the coming episode. Hello and welcome to this episode. In this episode we have another exercise which is called separating digits. So write a program that inputs an integer between 1 and 32767 and prints it as a series of digits with 2 spaces between each digit. For example, 4562 should be printed as 4, then 2 spaces, 5, 2 spaces, 6, and then 2 spaces, and then finally 2. Go on and try to solve this problem and come back to this video for the solution. Hello and welcome back, and this is the solution to the problem that we discussed about. Let me explain the solution a little bit for you so you can understand how it works. The first thing that we have done is that we have defined the prototype of these two functions. The first function is going to return the quotient of a division between the integer a and integer b. So this function is quite easy. You can see in here it only returns the quotient of a division operation between A and B. And obviously the return type of this function is going to be integer, because division of an integer by integer always yields an integer. The next function that we have is called remainder, and this function returns the remainder of a division between one integer and another integer. Next, we are going to start with the main function. First, we assume that the number is 0 until we get it from the user, and we define a divisor of 10,000. Then we ask the user to enter a number. We store that number here in this variable called number. Then we print this message: the digits in the number are, which is going to be printed regardless of the numbers. And from here on, the print of the number will start. Okay, so let's assume that the user entered this number 32454. Now we will check that if the number is greater than or equal to 10, then we will continue with the while loop. Why do we do that? Because the while loop will not continue if the number has become less than 10 and it has become only one digit. And if it's only one digit, we directly print the number without doing anything. But if it's bigger than one digit, then what we are going to do is that we are going to take this number and we are going to see if it's bigger than the divisor. Is it bigger than the divisor right now? 32,000 is definitely bigger than the divisor, which is 10,000. And that's why we are going to go and print the quotient of the number divided by divisor. So if the number is divided by divisor, and 3 is going to be printed. Now we are going to change the number to the remainder of the number divided by divisor. And if we divide the number by the divisor, the remainder will be 2454. Basically, this part that was printed will go away and the rest of the number becomes 2454. And we change the divisor from 10,000, which is divided by 10, it's going to be 1,000. So now the divisor has become 1,000. Now the while loop will continue once again, and it sees that the number is still greater than 10 and the number is still this number. So what we are going to do is that we are going to print the quotient of the number divided by divisor. The number is 2454 divided by 1000. It's going to be 2. The quotient will going to be 2. And finally, we change the number to the remainder of the number divided by divisor, and the main number will become 454. And the quotient once again will become 100. And the while loop will continue once again, and we still see that the number is bigger than 100. So we do the operation once again, and 4 is going to be printed on the screen this time. The main number will become 54 and the quotient will become 10. And the while loop will run once again, and what we're gonna have is that 5 is going to be printed on the screen. The number will become 4 and the divisor will become 1. And finally, when the while loop checks that the number has become smaller than 10, which is 4, then it will directly print the number itself, and finally the number 4 will be printed directly on the screen. And that's how this function works. Let's go and try running this once. Okay, I need to make these as comments. Let's go and try once again. Let's try 32454. You can see that the digits in the number are 32454. And that's it for this episode. See you in the coming episodes. Hello and welcome to this episode, and in this episode we have another exercise which is time in seconds. So write a function that takes the time as 3 integer arguments. for hours, minutes and seconds, and returns the number of seconds since the last time the clock struck 12 o'clock. Use this function to calculate the amount of time in seconds between two times, both of which are within 1 hour cycle of the clock. Go on and try to solve this problem and come back to this video for the solution. Hello and welcome back, and this is the solution to the problem that we discussed about. Let me give you a little bit of explanation for this solution. As you can see in here, I have declared the prototype for this function, which is returning the number of seconds. If you give it the format of hours, minutes and seconds, it will return the number of seconds calculated from the 12 o'clock. As you can see in here, the number of seconds function will calculate the number of seconds using hours that are going to be multiplied by 3600 seconds, and minutes which is going to be multiplied by 60 seconds, and the seconds itself. And this is basically how the number of seconds are going to be calculated. Now in here we have defined three integers, hours, minutes and seconds, which we are going to use to store the numbers from the user. And also we have these long integer variables, which we will going to store the first time and also the second time. So we are going to start with the execution of the program. We are going to prompt the user to enter a time in this format, hours, minutes and seconds format, and then we are going to use these variables to store those numbers, and we are going to calculate the number of seconds on the first time, and we store the number of seconds in the first time variable. Then we go again and we ask the user to enter the second time. We take those numbers in these variables and we calculate the number of seconds, and we store that in the second time variable. Finally, we are going to find the difference between these two times by using subtraction, and of course we have used the absolute value function in here because maybe the first time is smaller than the second time, then we don't want it to be a negative value, and that's why we have used the mat.h header as well. And finally we are going to print the number of seconds between the first time and the second time, and that is the difference that we have calculated. Now let's go and run this program once and see the results. As you can see in here, I'm entering the time in this format, 3 hours, 25 minutes and 26 seconds. And then the second time will be 4 hours, 25 minutes and 26 seconds. I want to make it the same so that we can see the difference and it's easy for us to calculate. So the number of seconds between the first time and the second time is 3660. 3600 is going to come from this 1 hour, and 60 seconds will come from this 1 minute that we have the difference in here, and there's no difference in the seconds as well. And as you can see, our program works well. And that's it for this episode. See you in the coming episodes.